All right, let's dive into something seriously cool today.
Sounds good.
NASA's got this incredible plan for exploring Mars.
Oh, yeah.
We're talking like their roadmap for the next 20 years, all the way to 2043.
Wow.
And we're going deep here. We've got, the public-facing stuff from nasa.gov.
Right.
Plus, we dug up this super detailed presentation they made just for the science community.
Oh, gotcha.
We can give you the inside scoop.
Yeah, like a behind the scenes.
Exactly. Insider insights.
Cool.
Like, imagine this, holding a piece of Mars in your hand.
Whoa.
And it might even have, like, proof of an ancient ocean.
No way.
Yeah, that's just one thing we're going to unpack today.
Okay.
We're talking sample return missions, tons of low-cost explorations, maybe even finding life, and get this, prepping for humans on Mars.
Oh, wow. That's a big one.
Huge. So, NASA's kind of changing their whole Mars strategy.
Really? How so?
They're moving away from those big one-time missions
Yeah.
and going for something way more sustainable, more frequent missions.
So like a constant stream of new info.
Exactly. Faster discoveries.
I like it.
But before we get too far ahead,
Hold on.
let's do a quick recap.
Well, history lesson.
Yeah. What have we learned from all those rovers and orbiters we've sent to Mars already?
I mean, where do we even begin?
Well, there's Odyssey, right?
Oh, yeah, that was a game changer.
Finding all that ice beneath the surface, at the poles.
And then Phoenix actually touched that ice.
Yeah, and even saw Martian snow.
Unreal.
Then you've got Spirit and Opportunity.
Our Martian explorers.
The dynamic duo proving Mars used to be warm and wet, like totally different than today.
And let's not forget, Curiosity.
Still going strong.
Still chugging along, yeah.
You showed us that Mars was once totally habitable.
Yeah, with liquid water, organic molecules, the whole shebang.
Amazing. Okay, what about the Mars Reconnaissance Orbiter?
Oh, MRO.
Our eye in the sky.
Sending back incredible images.
Plus, it helps other missions communicate with Earth.
Right, super important role.
And then there's MEV, the atmosphere detective.
Giving us clues about how Mars lost its atmosphere.
Yeah, turns out it lost its magnetic field billions of years ago.
And that's why the solar wind just stripped it all away.
Which makes things tricky for us humans.
If we want to go there, I gotta figure that out.
And how about InSight?
Yeah, our Marsquake listener.
Mapping out the planet's insides.
Pretty cool, huh?
But let's talk about the star of the show, Perseverance.
Okay, the celebrity.
Really collecting all those samples.
In an ancient lake bed.
Setting the stage for Mars sample return. Bringing a piece of Mars back to Earth, I mean, that's like straight out of science fiction.
It's huge.
Do you think those samples could hold evidence of life?
Maybe even current life. Who knows?
Whoa, that's crazy.
Mars sample return is like the holy grail of planetary science.
I can see why.
Imagine having those rocks and soil here on Earth.
To study with all our fancy equipment.
Exactly, stuff we could never send to Mars.
So, more than just fossils.
Yeah, it's about answering the big questions.
Was Mars ever truly alive?
Could there be hidden ecosystems underground, in the ice?
Whoa, an underground Martian world.
It's possible.
Okay, so we're looking for past life, maybe even present life. A&D, trying to find where life could exist.
The ultimate cosmic treasure hunt.
It's incredible, but it's more than just a treasure hunt.
Right, we're also laying the groundwork for something way bigger.
Humans on Mars.
Exact.
And the data we're gathering now.
Could decide where the first humans land.
That's a lot of pressure.
These robots are our pioneers, paving the way.
Finding those spots with ice that could be water and fuel for us.
Yeah, and studying the atmosphere and weather.
So we can predict those crazy dust storms.
Right, gotta keep our astronauts safe.
And they're even figuring out any health hazards.
Making sure Mars is safe for humans.
It's like prepping the planet for our arrival.
In a way, yeah.
But Mars isn't just sitting there waiting for us, right?
No way.
It's a dynamic planet with its own story.
Always changing.
So how's NASA going to explore that side of Mars?
So there's this third theme, discovering dynamic Mars.
Okay, tell me more.
It's about seeing how everything on Mars is connected.
The atmosphere, the water, the ice, the geology.
Yeah, how they all work together to shape the planet we see today.
It's like a giant puzzle.
Exactly, and we're putting the pieces together.
So we're uncovering Mars's past, present, and future.
It's ambitious, but fascinating.
That's a huge task.
Yeah.
What kind of missions are they planning?
Well, are we going to see another giant rover like Curiosity?
Or something totally different?
It's actually really interesting.
Okay, I'm intrigued.
NASA's taking a new approach, something like venture capital for Mars.
Venture capital for Mars, that's a new one.
Yeah, so think of it like this.
I'm listening.
They're diversifying their mission portfolio.
Instead of just one huge, expensive mission.
Exactly. They're spreading the risk.
So what, like a bunch of smaller missions?
Yeah, you've got low-cost missions, small and targeted.
Okay.
Then there are medium-class missions with bigger goals. And even competed payloads, where scientists and engineers pitch ideas.
It's like a competition to get your experiment to Mars.
Exactly. It's all about innovation and fresh thinking.
That's pretty cool, but with all these missions, don't we need a better way to, like, manage everything?
Mission control for Mars.
Yeah. And how do we even stay in contact with all these robots and get the data back?
That's where building a Martian infrastructure comes in.
Like what, a space internet?
Haha, sort of.
Okay, explain it to me.
So imagine a dedicated Mars telecom network, like a high-speed internet connection just for our missions.
Wow.
And then there's high-resolution imaging, basically making Google Earth for Mars.
So we can scout out landing sites and stuff.
Exactly, and analyze the terrain.
Smart. And what about those precious samples Perseverance is collecting?
We need a secure system to bring them back.
From Mars to Earth without anything getting, like, contaminated.
Right, it's called sample handling and receiving.
It's like a whole ecosystem for exploring Mars.
And it doesn't stop there.
What else?
NASA's investing in some seriously cutting-edge tech
Give me the highlights.
to push the limits of what's possible.
So like flying robots on Mars?
Maybe there are a lot of exciting possibilities on the table.
This is insane.
I know, right?
All right, well, break it down for me.
Let's dive into the details.
Okay, where do we start? So these low-cost missions, what are they all about?
They're like the scouts.
Scouts.
Yeah, nimble and efficient,
Okay.
taking risks, exploring new areas fast, and they're, budget-friendly.
So high impact but low cost.
Exactly.
Makes sense. What kind of science are we talking about?
It really varies. It could be anything.
Like what?
Studying rock formations,
Okay.
analyzing the atmosphere, maybe
Ah.
even testing new tech for future missions.
So like trial runs.
In a way, yeah.
Cool. Cool. All right, what about the medium class missions?
Now we're stepping up the game.
Okay, how so?
More complex, more capable. Maybe they'll deploy some serious instruments,
Right, yeah.
do some experiments right there on Mars.
On site.
Yeah, in situ.
Gotcha. Or maybe they'll explore some tougher areas.
Like canyons or mountains.
Whoa, that's intense.
One idea is to use a medium-class mission to set up a network of sensors.
Across the whole planet.
Yeah. Imagine that. Studying Marsquakes,
Oh, okay.
weather patterns, everything in amazing detail.
That's insane. Like a planetary scale lab.
Pretty much.
And then we've got the competed payloads.
This is where it gets fun.
I like fun. Tell me more.
Scientists and engineers basically pitching their dream experiments.
So it's like a science fair for Mars.
Aha! Exactly.
I love it. So anyone can submit an idea.
Well, anyone with the right expertise.
Right, of course. But it's still pretty open.
Definitely, NASA's really fostering innovation.
And who knows what we might discover.
The possibilities are endless.
So this is all super exciting, but what's the timeline?
When are these missions actually happening?
Yeah, do we have a schedule?
Well, NASA has a notional timeline,
Never
meaning
mind.
it's not set in stone, things can change.
Right. Space exploration is full of surprises.
And funding can be tricky.
Ah, yes, the money.
But for now, the priority is Mars sample return.
Okay, back to Perseverance.
Right. Gotta bring those samples home.
Remind me how that's going to work.
It's a multi-step process.
A relay race.
Yeah. First, the sample retrieval lander goes down.
Lands near Perseverance.
Exactly. Grabs the samples.
Okay.
Then launches them into orbit with a Mars ascent vehicle.
A mini rocket.
Pretty much.
Wow.
Then another spacecraft captures those samples in orbit.
And brings them back to Earth.
Yep. The whole thing should wrap up by the mid-2030s.
The mid-2030s.
Oh.
So we're talking like 10 years.
Give or take.
Wow, that's not that far off. Okay, so while we wait for those samples,
What else is going on?
yeah, what else are you excited about?
One thing that really blows my mind is
Hit me with it.
subsurface access.
Going underground.
Deep underground.
But like digging tunnels.
Drilling, actually.
Okay, and why are we doing that?
Think about it. We could explore ancient aquifers.
Underground lakes.
Possibly. Maybe even find signs of life hidden away down there.
Protected from the harsh surface.
Exactly.
So we're basically opening a time capsule.
A window into Mars's past.
This is incredible. What about human exploration tech?
What about it?
Any cool breakthroughs that could get us to Mars sooner?
Well, there's ISRU,
ISRU, what's that?
in situ resource utilization.
Okay, in English, please.
Basically, using what we find on Mars,
Like what?
water ice, for example,
Okay.
we can extract it from the soil.
And use it for...
Drinking water, even fuel.
Whoa, so we don't have to bring everything from Earth.
Exactly. Makes things way more efficient.
So it's like living off the land, but on Mars.
Uh-huh. Yeah, Martian survival.
Pretty smart. NASA's thinking long term.
Definitely building a foundation for the future.
But let's be real. When are we actually going to see boots on the ground?
The million-dollar question.
Right. What's the plan?
Well, this roadmap focuses on robots,
Okay.
but it's all about preparing for humans.
So the robots are the scouts.
Gathering data, testing tech.
Making sure it's safe for us.
Exactly.
But this is a long game. We're talking decades.
How do we keep the momentum going?
Yeah, how do we inspire the next generation
That's a key question.
to take up the torch?
Right, we need to get young people excited about space.
Show them that anything is possible.
Exactly, spark that curiosity.
Make them realize that they could be the ones going to Mars.
It's about the future of humanity.
It's a pretty amazing legacy to leave behind.
And it's not just about reaching Mars.
It's about the journey.
Exactly, inspiring the next generation to reach for the stars.
Okay, but let's be honest. There are going to be challenges.
Oh, absolutely.
What are some of the biggest hurdles we have to overcome?
Well, keeping humans alive and healthy on a multi-year mission, that's a big one.
Yeah, it's not like a trip to the moon.
This is a whole other level.
Yeah, it's a whole other level. So what are some of those challenges, like, specifically?
Well, landing on Mars safely, for starters.
Right, it's not like we can just use parachutes.
Mars has that thin atmosphere, remember?
Of course. So we need something way more powerful.
Exactly, and then there's keeping people alive for years.
Years, yeah.
We need life support systems that won't fail.
Oxygen, water, food.
All of it, and don't forget radiation.
Ah, yeah. Space is full of nasty stuff.
Gotta shield our astronauts from that.
Cosmic rays, solar flares.
It's a serious problem.
So many things to think about. It's mind-boggling.
And we can't forget the elephant in the room.
The money, right?
Space exploration is expensive.
Understatement of the century.
We need funding and public support to make this happen.
So gotta convince people it's worth it.
Exactly. Gotta show them the excitement, the discoveries.
The sheer awesomeness of going to Mars.
Make them feel like they're part of it.
So it's not just about the science.
It's about pushing our limits, about exploring the unknown.
Inspiring future generations.
It's about our place in the universe.
And who knows what we might find.
Maybe signs of ancient life.
New resources we can use.
Maybe even clues to solving problems here on Earth.
It's a win-win.
Absolutely. It's about more than just Mars.
It's about humanity's future.
And it's about changing how we think about space exploration.
How so?
Moving away from those one-time missions.
Those big, expensive ones.
And thinking more long-term, sustainably.
Building a lasting presence on Mars.
With robots and eventually humans.
So not just visiting, but staying.
Exactly. And there are a lot of reasons for this shift.
Like what?
Technology is getting better. We're learning more about Mars.
It's a dynamic planet, not just a dead rock.
And we're realizing that exploring Mars takes time and commitment.
It's a marathon, not a sprint.
Well said. We're building a bridge to another world.
A bridge of science, technology, and human spirit.
But there's still room for that sense of wonder, you know?
Yeah, the awe and amazement of space.
I think this new approach will actually make it even more amazing. Imagine classrooms following the missions live.
Kids getting excited about space.
People all over the world contributing to the research.
Citizen scientists.
Virtual reality experiences that put you right there on Mars.
Wow, that would be incredible.
It's about more than just sending robots and astronauts.
It's about bringing everyone along for the ride.
Expanding our minds, inspiring a new generation of explorers.
So, as we wrap up our deep dive into NASA's Mars plan, we want to leave you with this.
Think about what excites you the most about Mars.
What mysteries do you want to see solved?
And remember, this isn't just for scientists and engineers.
It's for all of us.
So keep looking up, keep exploring.
And never stop asking questions.
Until next time, space fans.